Dear participants of the 6th International Workshop on Computer Modeling and Intelligent Systems, greetings from National Aviation University, Kyiv, Ukraine. Let me share my screen with you and start my presentation. Hope it's in the progress, right? The topic of my report, hope it's visible and you can hear me well. So the topic is basic theoretical provisions of entropy approach for intelligent air transportation management. As to the problem statement, it's based upon Formula 1. This is a linear combination of the three members with the coefficients alpha, beta, gamma. This is this functional, objective functional, and it's a postulated view of functional. It contains entropy, subjective entropy, the first member, H with pi, subscript pi. This means it's also a functional of the function preferences pi. The second member is effectiveness function epsilon, and the last one, n, is the normalizing condition. Alpha, beta, gamma are corresponding structure parameters or cognitive internal parameters of psych for a decision-making person. So as to the previous approaches to such problems, in the literature review, you may find these statements about uncertainty of air transport management situation. It occurs in some different circumstances. So the management has to deal with the problems of reliability or flight safety, as well as the profitability and economic aspects of the system functioning. Thus, the problem becomes not a trivial, but very complicated and includes our individual's respect or attitude to some kinds of problems. And the postulated view functional has its roots in the well-known James's principle from theoretical physics, and also there are applications, but all those, for example, in neuroscience, neurofuzzy network synthesis and transportation challenges. So they have some solutions, either without considering uncertainty degree in the view of entropy member, either they do not consider air transportation management application. So for this purpose, I propose to consider the presented problem. In fact, Formula 2 says about that we are looking for preferences distribution that delivers as the argument these functions of preferences, they deliver extremum to the objective functional. Formula 2, it corresponds to Formula 1 at the statement of the problem. We're trying to find extremal value of objective functional. Well, as a kind of mathematical generalization of Formula 1, we have integral form, and first member, it's formula number 5, it's the entropy is the uncertainty measure for some period of time, t0, t1. It relates because this formula 5, it deals with the so-called instant preferences functions entropy and integral form, also for our effectiveness function and normalizing condition here as formula 6. But the main attention has to be drawn to the f-ith function, so actually objective effectiveness function according to each alternative considered for air traffic management, for example, or air transportation management. It may be in different form, in different view. It's proposed here, objective function number 8 is a kind of modification. And here, these f functions, they are in four following views, like objective function, its rate with respect to time, then combination, either product or ratio. And there also, there might be combinations between them, which of the members is evaluated or considered in the special problem setting. As illustration for the theoretical developments, there are, for example, 3 alternatives, 1, 2, and 3. So they are illustrated with the losses functions according to independent variable or argument sigma. It changes, but the tendency is the same and very simple linear function dependence. But nevertheless, the preferences themselves of these alternatives as the phase portrait or phase diagram with respect to the losses functions of according alternatives, they become significantly non-linear view. And you see there might be other problem settings to find the optimal value of some preferences functions in the framework of the general consideration. As to the entropy member itself, it has its own extremum in the view of maximum here, and it can be considered as to the argument optimal value for the period or the diapason of the maximal uncertainty. It's a separate scientific problem. So for this observing paper, I'd like to conclude that computer modeling with the application of the subjective entropy paradigm implemented to the transportation management intelligence system makes it possible to conduct a reasonably optimal governing activity based upon the theoretically substantiated provisions and results. So air transportation rational organization, it's very important, and it can be delivered or conducted with respect to the uncertainty in the view of entropy of our preferences functions in accordance with the effectiveness, objective effectiveness functions of corresponding alternatives. So thank you very much for your attention. Stop. Goodbye.